Can you guys start working on this question sheet, please? Any questions you can ask me. Hello guys, can you start working on this exercise sheet 2? There are 7 questions. I mean we may not have the time to work through all of them, but try to do as many as we can today, right? Okay. Alright guys, can you start working on the sheet, please? So there are, as I said, there are 7 questions. I'm gonna do. Can you first of all do question number 6, please? To start with, can you do question 6, please? Then I'll show you how to do. Just have a go at question number 6.
What have you been doing?
Huh?
The package that your colleague did for things we used it all because the minutes of the region pays off.
Which one? No, use Mathematica. I sent you the code last week. Try to use Mathematica. It's a command I sent to you last week.
There's an implicit region. I don't think
Alright, if you haven't done it, let me show you how to do question number 6, okay? So this is based on stuff that we covered last week in the lectures, right? You may remember you should have a random sample x1 to xn, and x bar denotes the sample mean, right? Then the expectation of x is equal to mu, and the variance of x bar is equal to sigma squared by n. This I showed you how to prove these two statements on Friday last week, right? Where mu is the expected value of x, and sigma squared is the variance of x, right? Now in this question here, we are told that x is uniform 0, 1. So your mu is what? It's gonna be, if it is uniform 0, 1, it's gonna be the integral from 0 to 1 of 1 dx, which is x, take the limits from 0 to 1, so it should be x times 1, so it's x squared by 2, so this is going to be half minus 0, so your mu is equal to half, right? And sigma squared is the expectation of the square of x minus the square of the expectation, right? So this is gonna be, this guy is gonna be the integral from 0 to 1 of x squared times 1 times dx. This guy here is half squared, right? This integral is easy, so it's x cubed divided by 3, limits 0 to 1, minus a quarter, right? So this is going to be a third minus a quarter, and this is 1 divided by 12. So your mu is a half and your sigma squared is 1 by 12. So therefore the answer is that the expectation of x bar is equal to half, right? And the variance of x bar is equal to 1 over 12 times n. Okay? Is that okay? I'm sure all of you got this right. This is, I did a couple of examples on this last week, so you should know, right? Any questions, guys? Yes?
Is n 10 in this case?
Huh?
Is n equal to 10 in this case?
Yeah, n equal to 10. So in this case, this would be, yeah, you're right. So this would be 120, yeah. Thank you. Yeah. So the variance of x bar will be 1 over 120. Any other questions, guys? All right, can you do the next question, please? So we just finished, you just came in, we just did question number 6. Can you move on to question 7, please? Oh yeah, there's a typo in this question. This should be x1 to x6. There are 1, 2, 3. There are 6 observations on the. As you can see, there are 6 data points. But so it should say on the left-hand side, it should say x1, x2, x3, x4, x5, x6. So let me correct that here. So there should be an x6 here somewhere. All right. So you have a random sample X1 distribution, and these are the sample. So the question is to find the joint probability that the sample So do you remember that? I did a simple question in the past. Anyway, let me show you guys. Hello guys, have you done question 7? Okay, let's look at question 7 if you haven't done it. So here you have X1 to X6 IID. IID means independent and identically distributed from a Poisson distribution of parameter lambda. So the question is to find the joint probability that this is the joint probability that x1 equal to this up to x6 equal to this, right? Now because these are independent random variables, right, this joint probability you can write as the probability that that's because of independence, right? And now you should know the probability mass function of a Poisson. I mean, it's in one of the links. If you go to the course website, you will see the PMF of a Poisson is E of minus lambda power x1 divided by x1 factorial like this, right? Now if you simplify this, there are 6 of this, right? 1 to 6, right? So there are 6 terms. You are taking the product over. So you get E of minus 6 lambda, then lambda power x1 divided by x1 factorial up to x6 factorial. Now we are given the values for x1 to x6, so you can input them. So this is going to be lambda power 9 plus 13 plus 6 plus 8 plus 10 plus 13. Is that right? 9, 13, 6. So these are the 6 values for x1 to x6, right? Divided by 9 x1 factorial is 9 factorial, x2 factorial is 13, 6 factorial, 8 factorial, 10 factorial, 13 factorial. So this is the joint probability of the 6 observation being occurring, right? Now the question is, what is the value of lambda which is more likely, right? They're saying that lambda can be either 10 or 12. So the question says that lambda is either 10 or 12. Now what you need to do, let me call this star, right? Star, the only thing that is unknown in star is lambda. So if you put lambda equal to 10 into star, let me check I don't have a calculator, so I need to check the solution, what the answer is. So if you put lambda equal to 10 into star, you will get star equal to approximately 5.907 times 10 to the power minus 7. It's okay to give up to 3 decimal places, so I don't expect you to give more than 3 decimal places. And if you put lambda equal to 12 into star, you will get 1.704 times 10 to the power minus 7. So this is the joint probability when lambda is 10, and this is the joint probability when lambda is 12. So which is more likely? 10, yeah, of course. So the answer is that since this is larger than this one, right? Lambda equal to 10 is more likely to occur. All right, guys. Any questions, guys? Please feel free. All right. Can you now do question number 3, please? Question 3.
Yeah, okay. Yeah, lunch.
Yeah. Where you want to go? Coffee, yeah. Yeah.
We're not so busy.
Yeah. All right. I mean, question 3 is basically part of the question is from probability 1, which I'm sure all of you took probability 1 last semester, right? So you should know how to do at least the first 2 parts, right? Using stuff that you learned, right? Okay. So let's see. Let's see how we can do it. Question 3. So you have these numbers 2, 3, 6, 8, and 11, right? So, and you're picking x1, x2, which is the first and the second number. The first part is to find the population mean, right? So the possible outcomes, it's always a good idea to list the outcomes and the probability. So when you pick x1, the possible outcomes is going to be either 2 or 3 or 6 or 8 or 11, and the probability is going to be 1/5. Yeah. So to answer the first part, which is basically asking you for the population mean, which is the same as population mean is the same as the expected value, right, of x1, right? So using this table, it's going to be 2 times 1/5 plus 3 times 1/5 up to 11 times 1/5. And if you do the math for this, you get this equal to 6, right? So that's the answer to the first part, right? The answer to the second part, which is to find the variance of x1, right? So this is expectation of x1 squared minus this, yeah. To find this, you will do the same thing. So it's going to be 2 squared times 1/5 plus 3 squared times 1/5, 11 squared times 1/5, and you take away from this the square of 6. Yeah. So if you do the math for this, you will get the variance equal to 10.8, right? So that's the first two parts. Now the third part is considering all possible samples, calculate the mean and the variance of the sampling distributions of x bar. Right? That we can answer this without actually doing all possible samples, because you know that this is your mean and this is your sigma squared. So a short way to answer question part 3 is to say that the expectation of x bar must be 6, and the variance of x bar is sigma squared by n, which is 10.8 divided by 2. I mean, this is a short way to answer the part 3 of the question. But the long way to answer this question is to list all the pairs, right? And then work out the expectation of x bar and the variance of x bar, right? I mean, this is using the formulas that I mentioned before. This is actually mu, this is sigma squared by n, where your n is 2, right? I'll show you the long way to answer the question is as follows. So let me show you the long way. The long way is to write down all the possible pairs that you can have when you draw with replacement. Remember, you're doing it with replacement, right? So first of all, you need to write down the outcome and the possible value for x bar. But the outcomes can be 2, 2. I mean, let me write down all of them. 2, 6, 2, 2, 8, 2, 11, 3, 2, 3, 3, right? And so on until I'm not going to. The last one will be 11, right? So these are the possible outcomes that you can have when you draw with replacement, right? Okay. and the corresponding values for x bar. X bar in this case is 2, in this case is 2.5, in this case is 4, in this case is 5, in this case is 6.5, in this case is 2.5, this case is 3, and in this case is 11, right? You follow me? Yeah? Alright, now once you draw on this table, the next thing to do is to construct another table. Each of these pairs have equal probabilities, and you have 3, 5, 30 different pairs. You have 30 different outcomes, right? And each of them have probability equal to 1 over 30, right? Okay, so the next thing you need to do is to have another table where you list the values for x bar and the corresponding probabilities, right? So here the possible values for x bar is going to be 2, 2.5, 3, 4, 4.5, and the largest possible value for x bar is 11, right? And to find the corresponding probability, you need to count how many. For example, to find the probability that x bar is 2, you need to go back to this table and count how many of the outcomes on the first column correspond to x bar being equal to 2. And if you do that, you will see there are 25 outcomes, but you will see there is only one outcome. There is only one out of these 25 outcomes that corresponds to x bar being equal to 2, right? Okay, and similarly for 2.5 there would be 2 outcomes. For 3 there will be 1 outcome. For 4 there will be 2 outcomes. So this is 4. And for 4.5 there will be 2 outcomes. And finally, if you continue this for 11, there will be 1 outcome out of 25 that gives x bar equal to 11. So once you got this table, right, then you can use this table to find the expectation and the variance of x bar. So for example, to find the expectation of x bar, all you have to do is just multiply these numbers with these numbers and add them up. Are you following me or not? Right, you just multiply these 2 columns together and add them up, and you will get what we got earlier, which is 6, right? Right, and to find the variance of x bar, you use this formula here. But to find the expectation of the square of the x bar, you multiply the square of this column with this column, right? So you get things like 2 squared times 1 over 25 plus all the way up to 11 squared times 1 over 25 minus 6 squared, right? So this is all in brackets, minus take away 6 squared. And if you simplify this, you will get what we got earlier, which is 5.4. Right. So this is the long way to do it, but this is the long way of doing part 3 of question 3, right? Where you have to create 2 tables. I don't know whether all of you follow what I said, Kanna? Yeah. You have to create 2 tables. The first table is this one, where you have outcomes on the first column and the possible values of x bar in the second column. And the second table gives you the distinct different values for x bar and the corresponding probabilities. These probabilities are obtained by looking at the first table, right? Okay. And once you got the second table, you can work out the expectation and the variance of X bar. And you will get the same answers using the shortcut. Alright guys, if you have time, can you do question 4 please? Don't know how much, we got only 3 minutes left, but can you try to do question 4? You need to list exactly like that. You need to list them. Yeah, you need to list them. Well, you can do it, but I think it would be easier to actually list the outcomes and then the probabilities, right? Do it in the way exactly that it is. I'm not sure if that was correct or not, but I think the best way to do it is to use the well, you can do it in a shortcut, but I think it's easy to make mistakes if you do it like this. And best to do it in the way I did it with the tables. The tower placement here, you're drawing 3 numbers, right? So 349 and 311 and 311. You can have 371, you can have 371, you can have 373. There are many different options you can have. Because the probabilities are gonna, when you do it yourself, the probabilities are not the same. The probabilities are not the same. When you do it completely, they are the same. So you can't apply the shortcut in this case. So the probabilities are not the same. So you have to do it the long way. You need to do it the long way for question 3. Question 3, you're talking about question 3. So you got the same answer as you said the same answer as yeah, it should be the same answer. No, and it's true, and it's the number of drawing. Alright guys, the 4 solutions to all the 7 questions are on the course website. Hi. Yeah. So please have a look at the course website when you have time. Right. I think there's another guy coming in. I think we need to leave.
Yeah, he just looks at me and just like pointing at his watch.
I don't know where he's going. You go for lunch.
Yeah, I'm starving. I haven't eaten. No, I don't think anybody knew that I was helping the class. Nobody asked me anything.
Yeah. I told Colin that you started helping last week. Yeah, you should get paid, man. I don't know why he's sending all these forms. It's really a hassle. It's a hassle. It's really a hassle. I don't know why he doesn't